Hello everyone, welcome to Unravel Logic channel. In today's video, we will learn about quantiles and percentiles. These are small concepts but very important to understand. Okay? Quantiles and percentiles. So let me start with a question. Let's say someone scored 65 marks in an exam. 65 marks in an exam. Is that a good score or a bad score? Most of you might say that it depends on what others got. Okay, so it depends on what others in the class scored. So let's say if there are 5 people who appeared in that exam and 3 of them scored above 90. So 3 of them scored above 90 out of 5 people. Okay, and if you consider this information, then 65 is not really a good score, it's a bad score. But then notice, what did you do in your brain or mind to reach to a conclusion that 65 is a bad score? You compare all the numbers and then you saw or realize that majority is above 90, then this one falls in the minority, so this is not good, this is even below average. Okay, so this process that you thought or performed in your mind to reach to this conclusion, what is this, right? This is something which relates to quantiles and percentiles, and this is what we'll understand today. So quantiles and percentiles are tools that help us understand where a number lies in a group of numbers and not just what it is. So if you see 65 on a face value, some might say it is a good score, some might say it is a bad score. But to truly understand whether it's a good score or a bad score, you need to also know about the other numbers in that dataset. So that process of comparison, the tools that allow you to compare that are quantiles and percentiles. Let us start with the quantiles first. So quantiles. As usual, let us see the formal definition. So quantiles are values that split sorted data into equal parts. Split sorted, this is important, sorted data into equal parts. Q quantile divides sorted data into Q parts. So Q quantile divides sorted data, again this is important, sorted data into Q equal parts. Okay, so let us understand and see different types of quantiles. So basically let us understand this and this. Okay, different values of Q will give you different quantiles. Let us understand those. So imagine you are standing in a queue of 100 people. So understand that there is a queue of people, okay, and the queue is of 100 people, and right now I'm drawing just random people who have different heights. Okay, but in our example all these heights are ordered, so this would be the smallest, then this would be taller than this person, and this would be further taller, and so on. So there are 100 people, okay, ordered by height. So this is less, this is more, and so on till 100. And you are standing somewhere in the queue, obviously ordered, okay. Now consider, and just keep this, for example, diagram in your mind for some time, okay. So we have type, parts, so type, parts, example. Parts is nothing but this thing, q equal parts, okay. These are the parts. So divides sorted data into q equal parts. So how many equal parts will be dividing that data into? Which data? People standing according to their height, sorted, and there are 100 people in that queue, okay. So this is important, 100 people. So first let us understand median. Median divides the data into two equal parts. So two parts, 50-50, okay. So 50 people left, 50 people right, okay. So this is your median point, okay. So two people on the right, two people on the left, if we consider these four people only. But if we are considering total 100 people, then median would lie somewhere between let's say 50 and 51, okay, wherein on the left side there would be 50 people and on the right side there would be 50 people, okay. So that is median. Again, this is a type of quantile, okay. Quantile. So median is a quantile which divides the data into two equal parts. In our case, 50 people on the left, 50 people on the right, okay. What is another type of quantile? It's called as quartile, okay. So this is quartile, okay. This is not n, this is r, quartile. So what is quartile? Quartile comes from quarter, okay. So if you might have guessed. So four parts, let me write it in the proper color, okay. Four parts, 25% each, okay, percent each. So which means if I see the example, first quartile would be the person standing on the 25th number, okay, or 25th person in the queue. Third quartile would be the person standing on the 75th number or 75th person in the queue, okay, would mark the third quartile. Okay, we'll understand what is the significance of this, but first let's understand what are the different types of, okay, quantiles. So then we have quintile. So quintile is 5 parts, which is 20% each. So if you were to divide 100 into 5 equal parts, it would be 20, okay. So one part would be consisting of 20 people or 20 persons if we go by our example. So second quintile will give you 40th person, okay. So it's nothing but 20 plus 20. Okay, this is first quantile, this is second quantile, and if you add this two, it would be on the 40 person mark, so it would be 40th person. Okay. Then decile is something which divides the data into 10 equal parts, so 10% each. One part is 10% of the data. So 7th decile is 70th person, first decile is 10%, second decile is 20th person, third decile is 30th person, and so on. 7th decile is 70th person. Now last one, this is important. So last one is percentile. Percentile is 100 parts. Okay, so 1% each. Okay, so if you see 90th percentile, and you must have heard it numerous times if you have given any competitive exam, 90th percentile. So this is nothing but marks the 90th person in your queue. Okay, and 90th person can also be marked as 9th decile. Okay, if we go by the decile terminology, okay, which we just studied here. So just like 7th decile is 70th person, 9th decile would be 90th person. And percentile, 90th percentile is equal to 90th person because each part is 1%. So if you want to get the 90th part, it would be 90th person and 90th percentile. Okay, 90 percentile. Okay. So percentile is just a quantile where data is divided into 100 equal parts. Okay. So I'm saying that because percentile is also one of the topics of this video. Yeah. So percentile is just a quantile where data is divided into 100 equal parts. Okay. Percentile is just a quantile where data is divided into 100 equal parts, 1% each. Now let us understand how to find a quantile. Okay. Nothing but mathematical formula. Okay. How to find a quantile or percentile, because we'll just use quantile, okay, if we are discussing it generically. Okay, so how to find a quantile? So let's understand that you have a sorted data set. Let's say data set sorted, the data is 10, 20, 30, 40, 50, 60, 70, 18, 90 and 100. Okay, this is our data set and this is sorted. So the formula is something like this. Okay, so let me write it here. Okay, it doesn't really matter. So formula is something like this: P times n plus 1. Okay, so this is nothing but the quantile in decimal format basically. And for example, 0.25 would be the value for 25%. Okay, and this is nothing but a number of data points. So in our example, these are 10 data points. Okay, and if you want to find the third quartile of this data set, okay, so let us understand what I mean by quartile here. Third quartile. Okay, so 1, 2, 3. So 1, 2, 3, 4. 4 parts you have divided this data into, and basically these are 4 quarters. So each is like 25%. Okay, 25%, 25%, 25%, and 25%. And we want to get the third quartile. So this would be the third quartile. Okay, third quartile, and this is nothing but 75%. Okay, how 75%? 25 plus 25, 50. 50 plus 25 is equal to 75. So 75%. Okay, 75%. So now let's put this in the formula. So 75% we need to find out. So if we just write it here, it's 0.75. We need to do it in the decimal format, right? So 0.75 times 10 plus 1. This would give me what, something around 8.25. Okay, so 8.25, what does this 8.25 means, right? So this is nothing but the position. Okay, so if you see the positions, this is 1 2 3 4 5 6 7 8 9 10, right? So 8.25 would lie somewhere in between. Okay, somewhere here. Okay, so whatever that number is as per your data set, that would be your third quartile. That would mark the third quartile in your data set. Okay, so this complete thing from here to here, wherever that 8.25, whichever number that 8.25 is, this whole thing is your third quartile. Okay, all right. So now we have the formula. We have seen the formula, and formula is clear. And so intuitively, right, if we now understand the intuition, what is the intuition here? That what we have just found out is nothing but finding the percentage of data that lies below the P mark, or in our case 8.25 mark. Okay, so what percentage of data lies below the 8.25 mark in our data set? Okay, so we can simply say it's 75% of data, because we just found out the third quartile. Third quartile is 8.25. Third quantile is at the 8.25 mark, and what was the percentage that we used? We used 75%. Okay, as per the quartile terminology. So we can say that all the data which lies before this 8.25 mark is nothing but the 75% of the complete data. Okay, and note that this is beyond 80 is because we are not starting from 0. If we had started from 0, so if first number would have been 0, then it would exactly be 75. Okay, the 75 would be the number which would mark the third quartile, or your 75% of data would lie behind that number or mark. Okay, so just because we started from 10, this is our 0. Okay, in this particular case, and that is the reason your 75% mark is beyond 80, after 80 basically. Okay, this understood? So this is what a quantile is, finding the percentage of data that lies below the P mark, Pth quantile, whatever. Yeah, so if you are at the 90th percentile in height, let's go back to this example. So if you are at the 90th percentile, you can simply say that you are taller than 90% of the people in the group. Okay, you are taller than the 90% of the people in the queue. Okay, now if we consider the example, so if somebody says that they have scored 98 percentile in a very prestigious entrance exam, right? We are simply saying that 98% of the people scored below whatever marks that person has got who has scored 98 percentile. Okay, this is what we are simply saying. Okay, so 98 percentile is different from 98%. Okay, all right. 98 percentile is comparing all the data. Okay, and basing it as 0. Okay, so this is what that percentile is doing. It is creating a new scale where 0 is your first number, whatever is the first number in your data set. Okay, percent considers everything from 0, but percentile or quantile allocates a new 0 as per whatever quantile that you are using. Okay, and we have already considered uh, the exam example. Okay, so if you scored 83 marks and are at the 85th percentile mark, okay, that means 85% of students scored less than you. So 85% of students scored less than 83 marks. Okay, and you can also say that you are in the fourth quartile. Okay, so 83 marks, 85 percentile. So 85% of the people scored less than 83 marks, and you can say you are in the fourth quartile. Okay, so fitness app. So for example, if a fitness app tells you that you slept better than 70% of the people, it is simply saying that you are at 70 percentile mark. Okay, 70 percentile. So slept better than 70% of the people, it means that you are at the 70 percentile mark. Now, income distribution. So let's say your salary is at 60 percentile mark. Salary is at 60 percentile mark. That simply means that 40% people earn better than you. Okay, so 40% people earn better. Okay, or 60% people earn lower than you. Okay, this is what it means. Now do note that data is always sorted first. Again, let me emphasize sorted. Okay, data needs to be sorted before you are doing any kind of percentile, quantile, or whatever calculation with respect to these two concepts. Okay, now when to use quantiles or percentiles. Okay, when to use, always used in a data set. Okay, so the data is not like free flowing. Okay, you need to create a boundary wherein you would put all the numbers, and this whole boundary, whatever lies in this boundary, is a data set, and then you are comparing the data in that data set. Okay, that is where you would use quantiles or percentiles. So used when comparison is needed within the data set. Okay, comparison needed within the data set. Okay, for fair comparison, that we have already seen, right? And quantiles define relative scale for your data set, that I have already explained using this example, that it considered 10 as 0, and then relatively it gave you the comparison, the right comparison. Okay, now one important use case for percentiles or quantiles is outlier detection in your data. Okay, so this is important, outlier detection in your data. Okay, So for that, let's understand another concept which is called as IQR, or simply called as interquartile range. Okay, so the range between two quartiles. Okay, formally IQR is Q3 minus Q1. So difference between the third quartile and the first quartile, which is nothing but a middle 50% of your data set. Okay, how? Q3 is 75% and Q1 is 25%. So that gives you 50%. Okay, that is the reason it is called as middle 50% of your data. Okay, so how do you detect outliers? Let us consider a data set. So we have this data set, and note that this data set is sorted. Okay, so Q1 is 50, Q1 lies at the 50 mark, and Q3 is at 75. Okay, so basically these numbers. So this is Q1, this is Q3. So Q1, Q3. And if we find the IQR, this would be Q3 minus Q1. So Q3 is 75, then minus 50. So you get what? You get 25. Okay. Now there is a rule for outlier detection. So in your data, so you need to have a lower threshold and then you need to have a higher threshold. Okay, so I'm just marking them arbitrarily right now. These are not the exact thresholds, but whatever lies behind that threshold, okay, and whatever lies above this threshold, okay, these can be called as outliers. So how to find this threshold? Okay, how to find this? There is a rule. So lower bound, the formula is Q1 minus 1.5 times the IQR. Okay, because we have to find this behind the quartile 1, so that is the reason we are subtracting from quartile 1. Okay, so this thing, so this is Q1 and we want to find that lower bound behind, which should be behind this. Okay, so that is the reason we are subtracting from quartile 1 so that we get the value which is lower than quartile 1. Okay, here. Okay, and similarly upper bound, this is Q3. Now we need to find here this side, right side of the Q3. Okay, so we need to add 1.5 times IQR. Okay, and if we apply this formula to our use case, LB would be 50 minus 1.5 times 25. So this would be 12.5, and upper bound would be 50 plus 1.5 times 25. This would give you 112.5. Okay, so if you notice these numbers, okay, so anything, okay, which would, let's say there were more numbers here. Okay, so we had, for example, let's say 35 and then 10 and 9, right? And then here we can have 115 or 120, right? If we extended this. Okay, so what this would mean is that, see, 10 and 9 are less than 12.5. Okay, further to, so somewhere here would lie at 12.5. Okay, so we can discard 9 and 10 as outliers as per the lower bound that we have got, and this is the lower bound. Okay, this is nothing but lower bound, and here we have 112.5. okay, so this is the upper bound. So anything that lies beyond this, for example 115 and 120, so these are nothing but outliers. So this is how IQR or interquartile range or quantiles help us in detection of outliers. Now, one question can be that why are we using this multiplier is 1.5? Who came up with 1.5 or why is it 1.5? So I won't go in too much details, but see, this is, you understood why we needed this, right? For outlier detection and how we detected the outliers and how we found out the lower bounds and upper bounds, right? So there was somebody who did a lot of hit and trial, lot of experimentation and lot of experience with previous data or past data. Okay, and this multiplier came out to be most suitable, and that is the reason it is chosen as this multiplier, this value 1.5, because it gives us the best results. Okay, and the results are not too close to the interquartile range. Okay, because this, if you see in a sorted data set, this would be the data which would be very close to the central tendency of your data, for example mean, median, right? This particular set of data, okay, which is nothing but the median 50% of, or like middle 50% of your data, right? And anything that lies on this side of it or that side of it can be discarded as outliers, and this 1.5 gives you the best results. Okay, this is the reason it is chosen as 1.5, and this is the reason it is 1.5. Somebody has already done a lot of experiments and hit and trials on the previous data sets. Okay, so that's it for today's video. I hope I was able to explain you quantiles, percentiles, their importance, how to find these, their mathematical intuition, and when to use these, and what are some applications of quantiles, for example outlier detection. So thank you for watching. Please like, share and subscribe, and comment if you have any feedback or if you want me to cover any specific video. Okay, thank you. See you in the next video.